guess, but
Which number 6? Oh, the 2x over x minus 2? Okay. So, I'll just write it down. So we have 2x. This is number 6 on the first page. I think it's the only number 6 on that one, so that's good. X minus 2, subtract 4x minus 1 over 3x plus 2 equals the 17x plus 4 over 3x squared minus 4x minus 4. So what times what is negative 12? You add together to get negative 4. Negative 6, 2. So this becomes 3x squared minus 6x plus 2x minus 4. So you get 3x, x minus 2, positive 2, and x minus 2. So your terms here, when you factor this out, it becomes, oh, lo and behold, 3x plus 2 and x minus 2. Relatively convenient.
I probably can't just always assume it's like that, but in this type of problem, it's usually just going to factor out to be the one thing.
It can, yeah. I mean, isn't it quicker to FOIL and check than it is to factor? Yeah. It's always a rule of thumb. I would try that. Maybe if you want to go that route.
Oh yeah. What do you mean by FOIL and check?
like
What's 3x squared minus 6x plus, you see what I'm saying? You can check that quicker than you can factor usually, so it doesn't hurt. So our common would be the 3x plus 2, x minus 2. So as you go to distribute all that through, remember the idea here is we're going fraction by fraction, checking what part has what, and then just go on from there. The first one has the x minus 2, and it needs the 3x plus 2. Oh, plus there. Minus the, this is where most of you will screw up, is that you've got the subtraction part. Most of you guys will mess up here. You'll FOIL this fine, but you'll forget there was a subtraction in front, which means you had to distribute the negative. That's usually where people will mess up. First term here gives me 6x squared plus 4x. This is 4x squared minus 8 minus 1, so it's minus 9x plus 2. Distributing my negative gives me minus 4x squared plus 9x minus 2 minus 17x minus 4. It's 0. And a partridge in pear tree. So I moved all that. I just moved all that over to set it equals 0 because I knew I had to do that eventually anyway, so might as well get out ahead of it. Start combining like terms. Or the easiest way to do that is I like to underline what I'm working with first and just kind of go down the line. 13 minus 17 is negative 4. And then lastly is minus 6. I've got a GCF. It's equal, so I take the GCF out, doesn't change anything. So we have x squared minus 2x minus 3, which is x minus 3, x plus 1. I have zeros in it, 3 and negative 1, and I just have to double check to see if either of them are extraneous. Remember, extraneous solutions are solutions that can't work. I don't believe either of those were, because our terms were minus 2 and 3x plus 2. Yeah. So both of those would work. Okay? Sure. Usually it's that middle portion. Whenever there's a subtraction on the secondary parts where people screw up, so you forget to distribute the negative. That's usually what people will mess up. Yes, ma'am. We multiplied by, whenever you have an equal sign, you want to multiply it to get rid of it. Okay, I cross multiply. We're multiplying everything. Think of it this way. If I didn't want to deal with fractions, I would want to multiply everything by the common denominator. Okay? And In this case here, it would be 3 times 5 times 7. Okay. So, in essence, if I multiply everything by 3 times 5 times 7, it would look like this. It would be 3 times 5 times 7 times 2 divided by 3. 3 times 5 times 7 times 2 over 5 equals 3 times 5 times 7 times x. Or 7, sorry. So in each one of these, they become their own term. And it's all multiplying. The fractions then go away, because 3 divided by 3 is 1.
Okay.
5 divided by 5, and 7 divided by 7. It's the exact same thing, but I'm not writing that step here. Because if you look at it, first one has a 3, it needs the 5 and the 7. Second one has a 5, it needs the 3 and 7. So I'm saying that as opposed to writing it.
Okay.
Does that make sense? Because that's where a lot of people get disconnected on
And
this.
then you just build it.
Yeah, that's what I did on that other side over there. I said it equals 0, saying we had a quadratic. Yes, ma'am.
This one is like a cut it equal.
There's a couple of them that do that. I think the one above it does it too.
So because it's the same thing.
Yeah.
But if it's different, then would you have to put?
Then you got to do the counter. Yep. Yes, sir. Which 13? 13 on the first page? Okay. Hey, it's the only 13. Good deal. All right. So, once again, I'm going to start writing it out with the factored form. Okay? 2 sets of fractions, 2 sets of denominators. Need common denominators for both of them. Well, common denominator for the top one is going to be, well, they have one set of the x plus 5s in common. What's left? An x minus 5. Fraction on the left has them both, bless you. Fraction on the right needs the minus 5. So it's plus 2 times the x minus 5. So that new numerator then becomes 2x minus 6, I believe. All right. Second set of denominators, same common, x plus 5, x minus 5. This one's a little bit quicker. Need a minus 5, need a plus 5. So this gives me 2x over, and why is it 2x, not x plus x? Will you tell these bozos that fractions aren't bad? Fractions aren't bad.
Shut up, Will.
That was awesome.
That was very well played. Everything okay? Minus 5 plus 5 goes away. X plus x is?
2x.
All right, so now we have our same change flip. Your favorite time and mine. Oh, let's make it even more fun.
Right in silly colors.
I am. Ready? What? Ready?
You did that.
Notice what you have. You have 2x minus 6 over 2x. You can't get rid of the 2x, but what can you factor out of the numerator? 2. 2. Take out the 2.
Whoa.
And now you're complete. That's your x minus 3 all over x.
Wait, so the blue
This is still the fraction. This is still the fraction. I was just separating them up.
oh wait, I put it why should the denominator, can you cross out both of those and then the Like, what did you cross out?
These, when I flip these, so at this, at this spot here, same change flip.
Yeah, no, I get.
That's where these get crossed off. Okay.
Put up there.
She's talking about the negative 5 plus 5.
What's negative 5 plus 5?
Oh, okay. So they just cross out it. Okay.
And the next one. Okay.
Were you 14 on the other side?
That's one up on the top, right? Yes. Okay. So here we have 4 over x plus 2, 1 over x minus 2, 5x minus 6, x plus 2, x minus 2. Once again, it's a difference in squares, so it's real fast to factor. The common denominator to multiply everything by to get rid of it would be the x plus 2, x minus 2. Yep. That's technically what we are doing, but I'm not writing down that stuff. Like the same thing I did, like the 2 3s and the 7s. There's no reason to, because we know the plus 2s will go away in this one. The minus 2s will go away here. So what's left? That's why we say what's left. It'd be 4 x minus 2. 1 x plus 2 is 5x minus 6. So let's see, we get 4x minus 8 plus x plus 2. So what's that? 5x minus 6 is 5x minus 6. Is that a true or a false statement? So when it's a true statement, what is it? Infinite solution. But what can't it equal? Very good. This would be infinite solution, all real, x not equal to plus or minus 2. Remember when you get a true statement, like 6 equals 6, x equals x, that means all real solutions, all real numbers. But in this case, it's all real numbers except plus or minus 2, because those are your asymptotes. Okay? That's where that comes into play. Yes, sir? Any?
Number 7 on the.
No.
That's okay. It's fine. Rapid fire. Right away, I noticed something as I was writing this down. I can take out the 2 here, and this becomes 3x minus 1. Which means I can do a very fast. No. But what's that numerator become? 1. Don't forget that. Okay? Now you cross multiply, you get 4x minus 13 is 2 times 2x plus 5. You can simplify out ahead of it if you want. If you didn't, it would happen anyway. It would wind up working itself out. So you get 4x minus 13 is 4x plus 10. Oh no, that doesn't look good. We broke it. Last time I checked, negative 13 does not equal 10. So this is a no solution. Which these should be frowny faces.
That's very
I absolutely love it though. That's pretty good. All right, pretty good. It's more of a clown face than it. Maybe he's wearing a hat. And his hat is cool.
Oh, jeez. You're doing all sorts of crazy things.
And maybe it's snowy.
One in space?
So he just has to he's just covered himself.
Maybe there's a label on the
So then he had arms, and they were made of stars.
That's kind of God.
What's he use his buttons?
It is kind of scary. Maybe we'll have flowers for buttons.
His carrot nose.
There's no carrot buttons. Sorry. What else we got? That makes sense on that one. That's why that doesn't work. What's that? Yeah. Same idea. 8. Excuse me. 5x plus 2. 10x minus 3. X minus 8. And 2x plus 3. This one we actually have to do a bit of work on. We have to FOIL it out. So we get 10x squared. 15x and a 4x is 19x plus 6. 10x squared minus 80 minus 3, so minus 83x. And then plus 24. That sounds great. Hey, but look what happens with your quadratic part though. It's dead, yes, it's dead. He's dead, Jim. He's pushing up daisies.
Finally, it's good.
What's 10x squared minus 10x squared?
That was
Dead. So now I add 83, subtract 6. What was that? 102x is, what was that? 18. Three 17s. There you go. Bless you. What? Yes, guys. Hold up, guys. Which 14? There's 3 of them. Is it a complex one, this guy right here?
Yeah.
Hey, did you guys notice that there are 3 14s? Did you notice that? Lousy smarch weather. 5. Easy with the shite. Alright, ladies and gentlemen, here we go. Complex fraction. Guys, I got a couple other sheets I want to get to as well. Complex fraction, again, there's nothing in common. There's nothing in common in the top denominator, and there's nothing in common in the bottom denominator. So we have to multiply those two together separately. So we do that. We have 4 and an x minus 4, which means I get 4x minus 1 times the x minus 4. This is, again, where people will screw up because they forget the negative. So when you distribute and combine like terms up top, you're going to get 3x plus 4 over the 4x minus 4. Okay, when that all gets put together. Same deal in the denominator. We need 4x times the x minus 4. So when I start multiplying back and forth here, I get 9 times the quantity x minus 4 plus 4x cubed. All right, because it's 4x squared times, or 4x times x squared, this gives me 4x cubed. Simplify that secondary numerator. we get 4x cubed plus 9x minus 36 all over the 4x. Oops, sorry. I know, right? And then same change, flip. It was very annoying. And then what simplifies out, the x minus 4's go away. So all you're left with in the numerator is the x and the 3x plus 4. I always ask you, always distribute combined terms in the numerator. Denominator, we already did that because it was a numerator earlier. Your final answer would have been 3x squared plus 4x all over the 4x cubed, 9x, and minus 36. And there's nothing left to do on that one. I distributed the negative 1 in the combining terms. What's up? Very good. Yes, sir. I wasn't really worried about it. But thank you. Sure, I don't care.
I don't know, he's really a sensitive person. But it's good that
it takes a little bit more than those things to get me really peeved. That's so mean!
you just hate Kelsey.
I don't understand. She's trying to tell Cassie turns around. She's like, oh my gosh, I really hate her. I'm trying to make it subtle. She's like,
Yes, sir.
I have no idea.
I was 10, and this finger's famous. I'll show it to you eventually. What other style? Oh, actually, the other ones. Hold on, guys. Yes, sir. Hey, these are the sheets I told you guys that I posted last night. Guys, no. These are the sheets that I posted last night. I had, like I said, I had 3 of them. The answers are on there. Online. It's a software. It's a software that we purchased a couple years ago, and it's completely revolutionized how we do worksheets. It's so nice. You can put in what style of problems you're looking for, what type of that problem. I can go.
It's like an algorithm study.
Yeah, I have for like the algebra, because this is one that you're looking at here. I have all these different topics to choose from. So if I want to, so we deal with hyperbolas. I wanted to put some problems with hyperbolas. I can give you vertices and stuff. You can tell me then what the equation is, and so it self-populates through. It's really awesome. It's completely made. It makes it so much easier. Yeah. Did you guys get 3? Yeah, there's 3. I put 3 of them. Okay. Number 2. They're hoarding them. You guys should all have 3 separate. Now, real fast, let me get back to you. Said 15. Hey guys, give me a sec here, please. Before I get back over to the number 15 question, you should get 3 of these CUDA sheets. You need one more? 92? No, top right corner, there should be 3 different ones. There are ID1, ID2, and ID3. Okay? They're all kind of, as you see, they're same similar style problems in each spot. Yeah. Like I said, online, those are on there. And as you scroll through to the end of the PDF files online, these are the answers they give you. There are, with CUDA, it's not, I was just trying to find as many extra problems and styles and things as I could to help you guys out. Some of the answers look like crap. I mean, look at 15 and 16 here. It's just because, remember how we always say multiply out the numerators? Some of those numerators just get kind of big. And that's the only downfall of a few of those. But honestly, as you get into it, the math that got you here is easy. Yeah, there's a lot of stuff that works to it, okay? So, but just so you know, those are all those things are all posted up there with the answers just like this is going on. Thank you, sir.
So do you just take, for like 15, 16, you just take the UCFs of the X out? And then
No. I wouldn't even. I'll go to one of those and show you how it would look after I answer his 15. Okay. You said 15. Is it the 15 that's crooked on the bottom?
Yeah.
That was the only 15 I didn't know. All right, so 15 that's crooked on the bottom of the sheet from yesterday. We have 1. I'm going to factor it as I go. So I have 1 over x squared, x plus 10. Now it says divide by, so I'm going to flip this fraction right away, times x plus 3 over x plus 3, x minus 3. And then it's times x plus 10 over x plus 5, x plus 2. Oh, not 5, I'm sorry. That was 12, I thought it was 10. So it's 12 to be 4 and 3. At first glance, I thought it was 7 to get 10, so that's why I wrote that. So this one here, right off the bat, I've got everything factored. I shouldn't have to be talking this loudly. Just start going for what can you cross out? Well, I'm x plus 3, x plus 3, x plus 10, and an x plus 10. And that's it. So what's in your numerator now? 1. So when I write this out, I just write it as 1 over x squared. If you want to write that as x plus 3, x minus 3, that's fine. Or if you knew it was x squared minus 9, either one is fine. I probably would write x squared minus 9 because it's shorter. And then write it in an x plus 4. And there's nothing else to do. Okay? And that's what that would do. It's a denominator, so you don't have to. Yeah, like I was just saying, you could have just wrote x plus 3, x minus 3, x plus 4, just left it all there. It's just sometimes when you have it already pre-factored or pre-foiled, and for something easy like that, it's different to square. It's just faster to write it. So that's all you got to do. Okay?
I have a quick question.
Yes, sir.
But I have like a problem with 14 on this sheet, like on the front side.
Sorry, I was in mourning. What's that?
Have you ever dropped the blood?
No, drop times or drop this. I always flip this. Yeah, I don't think you notice that. That's what I'm always doing this, not even looking. And
Yeah. So on the other sheet, yeah, on the front, like 14, 13, 14, when I get like the same denominator for the top and the same denominator for the bottom.
he's this close. Sorry.
So when I get the same denominator for the top ones and then a different one but the same for the bottom, kind of ignore it.
I know what you're trying to do, and if you are, because you're looking a couple of steps ahead, that's fine. I'm not gonna say you can't do that. I like to do it all at the end as I'm going, so I don't forget something. Okay. You're not wrong. And thinking ahead.
So as long as I match the denominators,
You should be fine.
I can.
So, like I was saying, on some of these CUDA sheets, I'm looking at ID2, number 15, and it's a complex fraction. Okay, it's a complex fraction, but the value sets aren't terrible. Yes, sir.
Oh, I was just going to ask a question about when you worry about answers getting deleted. Remember when I did that weird thing where I tried multiplying stuff out and then solving normally rather than cross multiplying, and I just destroyed answers? When you have to worry about that.
With this stuff, yeah, with this stuff, you wouldn't have to worry so much because what answers that you're casting out wind up usually being extraneous solutions anyway. So if it was like an x minus 2, you had an x minus 2 that canceled itself out, that if you wouldn't have gotten that 2 as an answer anyway, and it wouldn't have worked. So that's kind of how the extraneous stuff works.
Yeah, more so that on the test, when it came to points where the denominators were all the same, I kind of worried about multiplying them out, but I wanted to multiply them out because...
Yeah, you don't have to do that.
Well, I mean, like, on either side of the side, the denominators were the same, so I just multiplied by the denominator to get rid of the denominator.
Yes.
Yeah, and I wasn't sure if I was deleting something.
Not by doing that.
Wait,
So, sorry. It's on the PDF file on the calendar. Again, on this one here, it just looks like it's going to be awful, but really, as you get going, it's not terrible. Common denominator here is 3x squared. Needs a 3, needs an x squared, so that's where we get x cubed plus 27. Okay. Down here, it's 9 times the x minus 6. X minus 6 gives me x squared minus 12x plus 36 plus 9x. All right. This would simplify in the middle here as x squared minus 3x plus 36. And then we have the 9 and the x minus 6. And then up top just comes across. So you have the same, which was the x cubed plus 27 over 3x squared. Change 9x minus 6. Flip. I didn't bother trying to factor the 36 to negative 3 because 9 and 4 is 5, and then after that it's like 12 and 3, so it's not going to get anywhere anyway. This case here, the only thing that you can simplify out is going to be the 9 and the 3, so this just becomes a 3 here. What's that? If I tried to factor this, its difference in cubes, it would give me x plus 3, then x squared minus 3x plus 9. It would have been nice if this was a plus 9, because then that would have dropped itself through, so it just didn't work. And so here, your final solution would have been x cubed plus 27, and then this was times 3x minus 18. And CUDA foiled that out. It's just gross. That's really all. That's why it looks so weird, because they foiled out the numerator with the cubic function. But it's just 2 terms. It's not terrible. It just looks awful. Yes. Always spoil out numerators. Don't have to do that to denominators. That's why it looked weird as you get to it. What other style that you want to look at here while we're cruising along?
8.
8 on the second one from yesterday. Yeah, so 8 is 2x, x plus 2, minus 8 over x, x plus 2, plus 3 over x. This is the one from yesterday, it's page 2 of it. So this one here, we have to get a common denominator and keep it because there's no equal sign. So the least common denominator here is going to be the x and the x plus 2. Okay? So first fraction has the x plus 2, leaves the x, so we get 2x squared. second one has them both, which is minus 8. And the last one needs the x plus 2. So we have to distribute out the numerator. We would get 2x squared plus 3x plus 6 minus 2. So or plus 6 minus 8 would be minus 2. What times what's negative 4? And I add the other positive 3. Positive 4, negative 3. So this becomes factorable. It became factorable, so we wind up with the final answer of x plus 2, 2x minus 1 over the x. Let's use this one. So your final solution would have been 2x minus 1 all over an x. Anytime you get a quadratic trinomial in the numerator, even though you just combine like terms and stuff like that, take a couple seconds to see if it is factorable. Sometimes it is, and it winds up being a term that you can take out. Okay? Sometimes it works. Remember the shortcut of doing that? 2x squared plus 3x minus 2. Isn't that 2, 3, negative 2? What are the two zeros of the denominator? Well, one of them is 0. What's the other 0 of the denominator? Negative 2, right? Huh. Negative 2 is 0. What are you left with? That would have been awesome.
That would. I really wish that was.
So you can't, there's many different ways of going through it. That's annoying. Very.
How do you do that?
I don't care. It's annoying. People were, it was annoying. I'm watching him do it and I hear sound.
They're not coming from him.
Bus. What else? Running the bus over him. That too. We'll run the bus over him. Safety! That kind of sucks.
Oh my god.
Yeah, then you were about to say something. Guys. Yeah. That's the easiest way to do it, yeah. Yeah. She's looking at here, guys. We have on 18 on the sheet from yesterday, there's one that says 7 over x plus 1. 7 over x plus 1 minus 3 over x minus 1. Big fraction 2 x plus 1 x minus 1 equals 3. So whenever you have a complex fraction equaling something, simplify the complex fraction first and then set it equal. So when we do that, this one, the top one's real quick. You get 7 times quantity x minus 1 minus 3 times quantity x plus 1 all over the x plus 1 x minus 1 times the x plus 1 x minus 1 over 2.
Oh, so that one.
That's what you're skipping, yeah, because you saw this, and after you get the common, you're doing that.
But if the top one is the same and the bottom one's the same but a different one, I can't do that.
Right.
Okay, so that's what I did.
That's why I'm saying try not to do that up front because you might miss it. Right. So here you just wind up with 7x minus 7 minus 3x minus 3, which is what? 10 or 4x minus 4 over 2. So you have 4x minus 4 over 2 is 3. And then you go from there. Does that make sense about how that goes? Simplify as much as you can the complex before you go to the e.
Okay, and then you solve for x.
Yep. Yep. And this one's really easy. You get 4x minus 4 is 6. X
That's
is
your math.
No, but yeah, 4x minus 4 is 10.
I don't know what he's talking about. But it's
oh, minus 10. Okay.
Yeah.
He's mad.
You're wrong.
The whole system is wrong.
Wait till the next
That's easy-ish. If you can math it right. Yes. And could X equal 4?
Yes.